Good morning, Sage Hens. There are 3 videos left for day one. This one will be pretty brief. I think so will the next one. The last one will be a more extended set of examples using truth tables. But this one and the next one will be the last little bits of the file. In this video, I want to talk a little bit more about types. The word type has come up a number of times already to refer to like a set of values or whatever. Coq is a typed programming language. Galena is typed. Every expression has a type. And facility with types, knowing your way around the type system is really important because types determine whether or not your program gets accepted. Types classify programs into good at some particular type and bad at no type, which means we will refuse to run them. Now, the languages you've programmed in until now may or may not be typed. Untyped languages are really popular introductory languages because you always get to run your program right away, even if all your program's going to do is crash. Sad face. Okay, so Coq is a typed language. You cannot run an untyped program. It's just not a possible thing. So keeping track of the types is really important. That said, the types tell you a lot. Once your program is type checks, you know you're well on your way to getting a program that actually works, which is something that is hard to say in programs without type systems. So you pay a price up front, but if you do it well, you get a few more guarantees to know that you're on the right track. Okay, let's look at types a little more. So we already met the check expression, which is a useful tool. Now, I've been starting to get a little bit annoyed that all of the responses are just down here in the corner. So a thing you can do for now is you can go up to the Coq menu and uncheck the box that says toggle 3 windows mode in Emacs. And then you'll get a view that looks something like this. I'm going to scroll it down a little bit, and this is, I think, a much nicer thing to read where we're going to get the responses down there. Later on, when we start doing proof, you'll want to toggle it back on. You might have to do this every time or otherwise edit your init.el file, but this should give us some nicer output right now. Okay, so what we have so far is that true is a Boolean. This is a thing we already know. That's how we defined true. Now, we can check compound expressions. I use parentheses here because I think it looks nicer, but you don't technically need them. You can just write this. And okay, negb true is also a bool. Well, why is that? Well, negb was a function. Here's its definition that takes a bool and returns it. So if you apply negb to a bool, well, makes sense that you'll get a bool back out. So control C, control dot takes me back to the end of my blue section. Convenient command to know. So check negb true says, hey, because negb takes bools to bools, that means negb true is a bool because we already established true is a bool. Now, negb itself is a value in Galena, right? It's a program, that's true, it's a function, but those are values too. So they have what are called function types, and we write them with arrows. The type of negb on its own, I would pronounce as bool arrow bool. Now what this means is that negb is a function that given a bool will return a bool back to you. Okay, so other functions have similar types. So orb. Orb is a function that takes 2 booleans and returns the or. Now this is the type we get out. And this is, I think, a thing that some people will find surprising. We'll be talking about these function types, the shapes of this function type, over the next 4 class days or so. So we're not going to resolve all of your questions now. As we get more experience, it'll become clearer and clearer to you what's going on. But the way we write the type in Coq is to say bool, arrow, bool, arrow, bool. Right? Orb is a function that takes a bool, and it gives you back a function that's waiting for another bool, and then if you give it that one, you'll get a bool back out. This is a bit to get your head around, but we can check it a bit with some examples. So let's see. Orb is a function that wants 2 booleans. What's the type of orb if you give it just 1 boolean? In many languages, the answer would be, don't do that. That's a type error. Orb wants 2 arguments. What are you doing? What's wrong with you? Don't you know computer science? I thought you had a PhD. Okay, interesting. It does work in Coq. It says, oh, well, orb is a function that wants 2 arguments. You've given me 1, so now I'm just sitting here waiting for 1 more argument. Orb true is an expression with the type bool arrow bool. That is, orb true is an expression that wants 1 more argument of type bool, and then you'll get a bool back out. So if you give it to it, orb true false, that's a term of type bool. You'll notice Coq is using the notation we defined up above helpfully. Okay, one thing that's a little bit annoying is Coq will always use this notation. So if you forget what the double bar symbol means, you're kind of in a rough spot. So just ask on Zulip if you ever see a notation you're not familiar with. The thing to do is whenever we define a notation is to memorize that one, and then keep a mapping in your head that says, oh, this is the same as the function orb. Okay, so these function types are a little bit funny. So let's go back to check orb. Um, bool, arrow, bool, arrow, bool. So this is really, you should read that as saying bool, arrow, and then I'm going to put parentheses, bool, arrow, bool. This is what's called right associativity. When you hear the word associativity, we mean where should you put the parentheses? If someone says right associativity, that means you should put them on your right. If you see left associativity, that means you should put them on your left. Okay. Now, what that means also is that application is left associative. So when we see or be true, false, that's really the same as this expression. This is how Cox sees it, right? That implicitly there are parentheses right here. Check or be true, false. And this should hopefully make some sense in that or be true we established up here is a function of type bool arrow bool. So if we take that whole expression and apply it to false, that's supplying the bool argument we needed, and the whole thing will have type bool. What happens if you do it wrong? Well, here are two things that don't make sense. So first, here's or be true false where we put the parens to the right, and we'll get an error. So the fail command here says I expect this to fail. If I don't put it, I'll get a real error. If I get fail, and blue won't advance. If I write fail, it says, okay, yeah, this failed just as I expected. Right? It says, let me scroll up so you can see the whole message. The command has indeed failed with message illegal application, non-functional construction. That's a lot of words. The expression true of type bool cannot be applied to the term false of type bool. This is a little opaque. It's not what you would call great writing. This is not prize-winning prose. But it is telling you what the problem is. The expression true cannot be applied to the term false. Why? Well, true is of type bool, which is a non-functional construction. The way someone who spoke English like a normal person would say this would say, oh, you tried to apply true as a function, but true isn't a function. It has type bool. Did you mean to write it some other way? Maybe your parentheses are wrong. There are, in fact, programming languages that are that helpful, but I am sorry to report that Galena is not one of them. So there's an art to learning to read these type error messages. Pros and cons. It is certainly a thing to get used to, in that the norm in computers is to give kind of accurate but bad information. And one of the things that you can do in your future as a computer scientist is maybe give accurate but good information. Turns out it's really hard. Okay, a syntax that you might also be familiar with would be something like this, right? Let me even remove the parens to make it more familiar, right? This is the notation we use in, say, algebra for writing down a function. This is probably also the notation you're familiar with from other math or other programming languages. And Cox can give us another error message, one that we won't totally understand quite yet. And it says, oh, true false has type bool star bool, well, it is expected to have type bool. We will know exactly what this error message means on day 4. But for now, basically, this is a thing. You can write this in Coq, but it doesn't mean what you think it does. It means something very similar. And we'll look at the relationship between this and the standard Coq functions later on. All right, but in any case, both of these produce failures. Okay, we'll see a lot more about types from now on. I wanted to prime you with some of the key ideas from types now, and we'll work our way up. Okay, 2 more videos after this. The next one will be a quick study using bioinformatics, and then after that, I'll do not like an informal video just on a whiteboard talking about truth tables a little bit. Okay, talk to y'all soon.